All right, now we're going to try a different shape now. We've done a line of charge, we've done a thin ring of charge, and we discovered that we can use the power of calculus to figure out electric fields for a lot of different shapes. So our next one is going to be an arc of charge. So I've drawn it up on the board. An arc of charge is going to be kind of a portion of a ring of sorts. And I just picked out some numbers, let's say 60 degrees here, and then minus 60 here. So we've got ourselves a pretty good sliver, basically 1/3 of a circle of charge. All right, now what I'd like to do is find the electric field at point P. So this arc of charge, I'm going to do is set it up so that the arc has negative charges on it. So if we look, these are minus charges. So we've actually taken this ring, this arc, it's very thin, and we've broken it down, we charge it with negatives in, and we take a look at the charge as being minus. Now, if we look, let's take a look at the electric field at point P. So our question is, what is that electric field at point P? So, well, we're going to do this problem just pretty much the same way we've done all of these problems. So let's take a little piece of this, and we're going to call this little segment a little bit of ds. So there it is, a little tiny chunk of it. And this little ds is going to have a little bit of dq on it, a little bit of charge. That's what we're really looking for. Now the question is, what direction is that electric field that's being created by that one little bit of charge? Well, if we look, remember it's a negative charge rod this time. So if I take my test charge out of its little case, open it up like so, and then place it at point P, what effect is this negative charge, a little dq over here, going to have at point P? And the answer, of course, is going to pull it in this direction, right along that way. Now, if I look, can I also have a little bit of ds down at the bottom here? So if I look at that particular charge created by this little segment ds right here, so we have another one right here. What direction is that test charge going to be pulled? And the answer is it's going to be pulled down in this particular direction here. All right, now when we look at this, it reminds me of the last problem that we had. We had a TP. So when we break these vectors down into their components, isn't there going to be a component towards the charged arc? But there's also a component here that goes up. And this one for the bottom, it also has a component going towards the charged arc. And doesn't it have a component that goes down? The component up and the component down, both of those are going to negate. Now, for every charge here, isn't there a corresponding one on the other side? And then there's one at 59 degrees, and then there's one at negative 59 degrees. And then there's one at 58 degrees, and then negative 58 degrees. So for every one, isn't there always going to be a corresponding one pulling it up, and then another one pulling it down? Another one pulling it up, another one pulling it down. So the only thing we really care about, if we get to the bottom line here, at point P, are the charges that are actually going in the direction of the arc. All right, if we look here, we've got a nice little angle here. These are our little DEs created by our little DQs. And if we look here, this segment on the bottom is going to end up being DE cosine of the angle. This definitely reminds me of the TP from the last problem.